Hello there! In today's video, I will tell you about all the ways to dissolve gold, and I will also demonstrate a good portion of them. This is not a tutorial, do not repeat anything shown in this video. Gold needs no introduction. Humanity has been obsessed with the shiny yellow metal long before we found any practical uses for it outside of making jewelry and coinage. Human lust for gold has built and destroyed civilizations. There is little man wouldn't do if a sufficient amount of gold is involved. From ancient times it has been revered for its unchanging nature and its undying luster. Indeed, the Tutankhamun funerary mask that was made more than 33 centuries ago is still as resplendent as the day it was made. Imagine how ecstatic the alchemists were when they discovered a mixture that could dissolve it. First and most known way to put gold into an aqueous solution is with a mixture of nitric and hydrochloric acid. Best results are achieved if the acids are concentrated and combined in a molar ratio of 1 part nitric acid to 3 parts hydrochloric acid. The alchemists who have discovered this mixture named it aqua regia, the royal water, because it can dissolve noble metals such as gold and platinum. Sadly, nitric acid can be quite expensive and hard to acquire, but worry not, there is a number of other ways of preparing chloroauric acid. All of them require a mixture of a source of chlorine ions. Most of the time this is concentrated hydrochloric acid, combined with a strong oxidizer. Such formulas are often referred to as poor man's aqua regia. So I have decided to test and compare some of those mixtures. Here you can see test tubes with concentrated hydrochloric acid and ramstick gold fingers. Going from the left to the right, we first have a control. To the second test tube, I added a small amount of bleach. The reaction immediately produced chlorine gas. Unlike in my video on mixing cleaning agents, chlorine gas here is a good thing because it is the oxidizing agent that will oxidize gold so it can be dissolved. To the third test tube, I added diluted nitric acid. And I also spilled it all over the stand. Shit happens. While far from optimal, even diluted nitric acid will still provide the same effect as concentrated, only it will be way less efficient and take more time. And acid, a greater volume of acid. To the fourth test tube, I added a pinch of potassium nitrate crystals I had made last week. Potassium nitrate should also work the same way as nitric acid. To the fifth test tube, I added a small amount of potassium permanganate, a strong oxidizer that should react with hydrochloric acid to produce chlorine gas. This mixture is known to dissolve gold, but it needs to be heated, which is something I won't do today, because I wish to compare those mixtures at room temperature. And finally, to the sixth test tube, I add a bit of a crushed pool chlorine tablet. As it says in the name, it's going to provide chlorine to the reaction. Here is a 1-hour time-lapse of the reactions. As expected, nitric acid did the best, with potassium nitrate coming in second. I have decided to give other mixtures more time and let everything react overnight. Now, let us see the end results. Here is the list once again. First, control. Just hydrochloric acid. It didn't do much. Gold is still the same as it was, but the acid vapors did corrode some of the copper underneath it. As you can see, the part of the finger that was above the acid line looks worse than the part that was in it. Now bleach. Bleach underperformed. It did dissolve some of the underlying copper, but did not dissolve the gold. The reason for this is its low concentration. Hydrochloric acid with an addition of diluted nitric acid completely dissolved both the gold and the copper. Mixture of hydrochloric acid and potassium nitrate did the same. Hydrochloric acid and potassium permanganate did nothing. This mixture needs to be heated near to boiling to work. Concentrated hydrochloric acid and pool chlorine tablets dissolved all of the copper and some of the gold. To dissolve the remaining gold foils, I would need to add more pool chlorine. Besides the methods that dissolve gold as chloroauric acid, there exists a second group of gold dissolving processes, that is cyanide leaching and its more ecologically friendly alternatives. Cyanide process is the most commonly used process in large-scale gold mining. It is based on the discovery that the gold will form a soluble complex in presence of cyanide ions and oxygen. Another essential part of the process is an addition of sodium or calcium hydroxide that is required to keep the pH above 10.5. This prevents the formation of hydrogen cyanide gas. The process is very effective, but also quite problematic. I wonder why. First of the alternatives is thiosulfate leaching. Other alternatives are glycine leaching, thiourea leaching, and iodine and bromine leaching. The last two utilize a similar chemistry to chlorine leaching methods I demonstrated earlier. Now let's talk mercury. Mercury dissolves gold the same way molten copper dissolves tin. It makes an alloy. Gold is still in its elemental state. What makes mercury special is that it is liquid at room temperature, and as such will alloy itself with solid gold, silver, and many other metals on contact. It is also one of the most toxic heavy metals that can cause permanent lung, brain, kidney, and nerve damage. While elemental mercury isn't the worst thing to handle, go watch Cody's lab for that, its vapors and salts are some of the worst things you can be exposed to. Thank you for watching. If there is any method I missed, or you wish to know more about, comment down below. I might make a video on thiosulfate leaching. Like, subscribe, and see you next time.